Hello everyone. So in today's video lecture, we will discuss about the difference between structure and union. So this video lecture will be covering introduction to structure, introduction to union, and the difference between structure and union. So first we will discuss about what is structure and what is the need of structure. So let us take an example. For example, I want to store information of a student, or I want to create database of a student in which I want to store student name, let's say student name, and the first information that I want to store is student's name. The second information that I want to store is roll number, and let the third information be the marks of this particular student in a single subject. So for this, I'll be using a variable, let's suppose name, which is a string itself. And for roll number, for example, I'll declare a variable int roll. And for marks, it can be either of float or integer type. Let it be of float type, float marks. So if I want to store information of a single student, I can take three variables, one of string type, another one is of integer type, and third one is of float type. And let's say if I want to store age of this student, then I'll be taking another variable of integer type, let's say age. So for this, I will need four variables to store four different types of information for a single student. And now let's suppose a situation where I want to store this particular information for around 100 students. So I'll be needing 100 into 4. That means 400 variables. So it would not be feasible to work with such so many number of variables. Another way is I'll create an array of names, another array for roll number, another array for marks, and another array for age. But that would also be not feasible. So is there any way where we can store the information of a student in a single variable? So this is possible with the help of structure. So structure is basically can be defined as a collection of different types of elements. Different types, or we can say heterogeneous types, in which we can store the different type of information in a single variable. And it is also a user defined derived data type. So first we will discuss how to declare a structure variable. Okay, the syntax for the same would be the keyword used will be struct. Then we'll be writing the tag name. Tag name is nothing but actually the name given by the user to the structure. Then starting curly brace. And within the body of the structure, we will write members. And so on. These members are nothing but actually the information that we want to store in this particular structure, along with a semicolon. So this is basically the designing of structure variable. Now, as we know, the memory is allocated to the variable only. Here, members will not be allocated any memory until and unless we have declared a structure variable. So first, before declaring a structure variable, first we have to design the structure. So here we have completed the designing part. Now, how we will declare the structure variable? Struct, tag name, then members, There can be any number of members depending upon the information that we want to store in this particular structure, and so on. So here we can write it like structure variable along with a semicolon. The variable structure variable can be declared outside the main function as well as inside the main function. So this is the format for declaring the structure variable outside the main function, and the format for declaring a structure variable inside the main function would be, we have to design the structure before the main function itself, and within main function, after designing the structure within main function, we can declare a structure variable as, first we have to write the struct, then you will write the tag name along with a structure variable. So this would be the syntax for declaring a structure variable. Now, once we have declared a structure variable, the memory will be allocated to the structure variable only, not to the members itself. Now, let us take an example. Let's say I want to store information, or I want to create a database, or I want to create a record for a single student of a particular class, in which the fields would be the student name, his name, roll number, and let's say marks in a subject. So how I will declare a structure? First, I will write the keyword struct. Then tag name would be the name given to this particular structure. A user can use any valid identifier for the same. Let's say I have given it the name student. Then the information that I want to store will be the member of this particular structure. First, I want to store the name. So char name. And let's take the size as 20. Then int roll. Float marks. And let's say int age. Now I'll declare a variable, structure variable, let's say S. If I want to store information of a single student, then I'll take a single variable named as S. Now how this structure variable will be allocated memory, let's see in the next slide. So memory representation of a structure variable would be the total size allocated to the structure variable will be equal to the sum of the size of each member of this structure. So here, this member name would be of 20 bytes. Roll will occupy 2 to 4 bytes. Then float marks will occupy 4 bytes. And age will also occupy 2 bytes. So the total memory allocated to this structure variable S would be equal to the 20 plus 2 plus 4 plus 2. That is equal to 2 plus 4, 6 plus 2 is 28 bytes. So if we look at the memory representation of this structure variable S, it would look like, here the structure variable S would be allocated total 28 bytes. Which the first 20 bytes will be occupied by name. Then next 2 bytes will be occupied by roll. Next 4 bytes will be occupied by marks. And last 2 bytes will be occupied by age. So this will be the memory representation of the structure variable S that we have declared in the previous slide. So as we can see here, each and every member has its own unique memory space, and all the members can be active simultaneously in case of structure. And we have stored multiple type of information in a single variable, that is structure variable S. So this is the advantage of structure. That means we can store different type of information in a single variable. Now let's discuss about union. Union is almost similar to structure. Let us take an example. The keyword would be union. Then we will write the tag name, for example, student. And the information that we want to store would be in the form of members. Say name, uh, and then we will declare a union variable, let's say U. So here the memory will be allocated to this union variable, which is U. This can be any valid identifier. So if we look at the memory representation of union, so the total memory allocated to union will be equal to the size of the largest member of the union. So in this example, here name is of 20 bytes, roll number is of 2 bytes, marks is of 4 bytes, and age again is of 2 bytes. So the largest member is of 20 bytes. So this union variable U will be allocated 20 bytes. So here this variable U have been allocated total 20 bytes. So first user will store name, which will occupy 20 bytes. Then if we store roll number, then it will occupy 2 bytes. Then marks will occupy 4 bytes, and age will occupy 2 bytes. So in case of union, all the members share a common memory space. So that is why all the members cannot be activated simultaneously. We'll have to access the members one by one. Whereas in case of structure, as the total memory allocated to structure was the sum of the size of each member, so each of its member has a unique memory space. So all the members can be active simultaneously. So this is the main difference between structure and union. Now let us discuss the difference between structure and union. The size of structure will be equal to the sum of the size of each member. Whereas size of union will be equal to the size of largest member. This is the major difference between structure and union. Because of the size of the structure and difference between the size of the structure and union, each and every member has its own unique memory space. Whereas in case of union, all the members share a common memory space. Since in case of structure, each member has its own unique memory space, so all the members can be active simultaneously. All the members are active simultaneously. That means we can access them simultaneously. Whereas in case of union, Since the members share a common memory space, so only one member is active at a time. Fourth difference is structure is less memory efficient. And union is more memory efficient as compared to structure. And the fifth difference is structure considered to be much faster as compared to union. The reason is because all the members are active simultaneously, so we can access the members at the same time. Whereas in case of union, it is slower as compared to union structure. So these are the major differences between the working of structure and union. Thank you.